Okay, concept 1, radical expressions. So at the top it's kind of cut off, but you can see I wrote objective. Our objective for this lesson is I can simplify and evaluate radical expressions. So by the end of this lesson today and when you come to class, we'll be able to simplify and evaluate radical expressions. So let's get started. Warm up. List the perfect squares, cubes, and fourths. Let me drop this down so we can see a little bit better. Perfect squares are numbers that, so 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36, 49. I also have these on my wall in my classroom. 64, 81, 100, on and on. Okay. These are pretty easy. Perfect cubes, these are numbers that you times them by themselves 3 times, and those are the numbers that you get. So these are also in my room. 1, 8, 27, 64, 125, 216, 343. Yes, you can memorize these too. 512, 729, so on and so forth. Okay, perfect fourths, you guessed it, numbers times themselves 4 times. So we have 1 times 1 times 1 times 1 is 1, 2 times 2 times 2 times 2 is 16, 3 to the 4th is 81, 4 to the 4th is 256, 5 is 625. These get really big really fast. 1296 for 6, 2401 for 7, 4096 for 8, and we'll stop there. I don't think we'll get any numbers bigger than that. Okay, let's break down the parts of a radical. The nth root of a real number a can be written as the radical expression nth root of a, where n is called the index. Whatever number you have right there, that is your index. Okay, this symbol right here is called the radical sign. Okay, and the number underneath it is called the radicand. Okay, if there is no index, there's no number written, it is assumed that n equals 2. Okay, if there's no number, we say square root, that we want this, we assume it's 2 for square root. Okay, all right. Number of roots. Give all possible roots to the radicals below. So square root of 16, remember when I take the square root of 16, I have 2 possible answers, a plus and a minus, and the square root of 16 is 4. Okay, square root of 121 is plus or minus 11. Square root of 289 does exist, it's plus or minus 17. Okay, and the square root of 4 over 25 is plus or minus, you take the square root of the top and the square root of the bottom. So the square root of 4 is 2, and the square root of 25 is 5. Okay, pretty easy. Let's do the cube roots now. So cube roots, I can only have 1. I don't ever do plus or minus because a negative times a negative times a negative gives me a negative, and a positive times a positive times a positive gives me a positive. So you will not have plus or minus with odd numbered roots. Okay, so 3, you will either have a positive or a negative, not both. So let's do this one. Cubed root of 8, we all know that to be 2. Okay. The cubed root of 343, well, if we come back up here and count, 1, 2, 3, 4, 5, 6, 7, it's 7. The cubed root of negative 125, well, that's negative 1, 2, 3, 4, 5. Negative 5. And the cubed root of negative 1 over 27, well, the cubed root of 1 is just 1. And the cubed root of 27, 1, 2, 3, is 3. Okay. So, odd numbers, no plus or minus. Even numbers, however, I can have either a plus or a minus, because I can go, if I come over here and I'll show you, negative times a negative times a negative times a negative. These two become a positive. These two become a positive. And a positive times a positive is a positive. So, even numbered roots, I have to have a plus or a minus because it's totally possible for there to be a negative number. So the fourth root of -1 is plus or minus 1. Ugh, I can't talk today. The fourth root of 2,401, if you go up here and count, 1, 2, 3, 4, 5, 6, 7, plus or minus 7. Okay? And the fourth root of 4,096, plus or minus 1, 2, 3, 4, 5, 6, 7, 8. So plus or minus 8. And then the fourth root of 81 over 16, it's still plus or minus. And remember, I could do this to the top and the bottom. So the fourth root of 81 is 1, 2, 3. And the fourth root of 16 is 2. So now that we've got some practice out of the way, let's fill in this table. Okay, so I kind of mentioned it up here. If I have an even index, 2, 4, 6, 8, even numbers, okay, and the radicand, the number underneath, is positive, there are real type of roots, and there are two of them. There's a plus and a minus. Okay? If I have an odd and positive, kind of like this example right here, my index is odd, my radicand is positive. I do have a real root, but I only have one, and it's positive. Okay? If I have an odd negative, like this guy right here, where the index is odd and my radicand is negative, I still have a real solution, but and I only have one, and it's negative. So kind of like this was -5. Okay? If I have an even index and a negative radicand, I have no real, I have imaginary. Because I cannot take the square root, cube, fourth root, sixth root of a negative number and get a real number. It doesn't exist. So I have an imaginary, but I have two imaginary. I have a plus and a minus. Okay? All right. So in the next video, we'll do some simplifying.